Have you ever stopped to wonder how that spoonful of sugar in your tea, that sweet bite of chocolate, or that fluffy pastry gets its sweetness? In today's video, we're going deep into the world of sugar, not just the science, but the industrial journey from plant to packet. We'll walk through the full process of how sugar is made in modern factories, from harvest all the way to crystallized perfection. Let's uncover how sweetness is engineered. Sugar primarily comes from two crops: sugarcane and sugar beets. Sugarcane is a tall, bamboo-like grass that thrives in warm, tropical climates. Sugar beets are root vegetables, more common in cooler regions like Europe, Russia, and parts of the EU. Both contain sucrose, the natural sugar molecule. Though they look very different, the process of sugar extraction is remarkably similar, with a few key differences we'll highlight along the way. For this video, we'll focus on sugarcane, but don't worry, we'll note where things differ for sugar beet too. First step, harvesting. Sugarcane is typically harvested once it matures at around 12 to 18 months. In many regions, this is still done manually using machetes, while in more industrial settings, giant machines cut the cane at the base, strip the leaves, and load it onto trucks. The key here is speed, because once harvested, sugarcane begins to deteriorate rapidly. Processing must start within 24 to 48 hours to prevent loss of sugar content. Sugar beets, on the other hand, are uprooted using harvesters, cleaned in the field, and transported in bulk to the factory. Once the sugarcane reaches the factory, it's first cleaned. Dirt, rocks, leaves, and any debris are removed. High-pressure water sprays wash the stalks thoroughly. Then comes shredding. Powerful rotating knives chop the cane into small fibrous pieces, increasing the surface area for juice extraction. For beets, the roots are sliced into thin strips called cosettes, ready for the next phase. Now, the sugarcane goes through massive rollers, like an industrial juicer. The process is called milling. Cane is passed through 3-5 roller mills. Pressure squeezes out the sweet juice, called dade cane juice. The leftover fibrous pulp, called bagasse, is not wasted. It's often burned to generate power for the plant. In sugar beet factories, juice is extracted using hot water in a process called diffusion, where sugar migrates out of beet slices into the water. The raw juice is cloudy, slightly greenish, and full of impurities. Next step, clarification. Here's what happens. The juice is heated to 100 degrees, 212 degrees. Lime, calcium hydroxide, is added to neutralize acids. Sometimes carbon dioxide is bubbled in carbonatation, or phosphoric acid, phosphatation, is used to help impurities coagulate. The mixture is then allowed to settle in large clarifiers. The heavy impurities fall to the bottom. The top layer, now golden and much clearer, is siphoned off for the next stage. Join the sweet transformation and show your before and after. Now it's time to remove water. This clarified juice still contains about 85% water. It's sent through multiple evaporators, large vacuum-sealed chambers where the juice is boiled under reduced pressure. As water evaporates, the juice becomes thicker and darker. After 4 to 5 stages, what's left is a syrup with about 65–70% sugar content. This thick amber syrup is now ready for crystallization. Here's where sugar takes its final solid form. The syrup is boiled again in vacuum pans, where sugar crystals begin to form. Seed crystals are added to help the process. As the syrup cools and boils, sugar molecules cluster and grow. The end result is a thick mass of sugar crystals suspended in molasses, known as masakuite. This process is repeated multiple times to extract maximum sugar, known as first, second, and third strikes, each with diminishing returns. The masakuite is then fed into giant centrifuges, like industrial salad spinners. Spinning at over 1,000 RPM, the machine forces molasses out through perforated drums. The remaining crystals are washed with hot water or steam. What's left? Beautiful golden raw sugar crystals. The leftover molasses still contains sugar and is often sold as animal feed or used in fermentation industries like rum and ethanol production. Next comes drying. The damp sugar is passed through rotating drum dryers or fluidized bed dryers. Warm air circulates to remove residual moisture. Once dry, sugar is cooled, very important to prevent clumping and ensure safe storage. Not all sugar is refined. Raw sugar can be used as is, especially in baking or for export. But for that iconic gleaming white sugar, the crystals are sent to a refinery, redissolved into syrup, filtered through carbon or ion exchange systems, recrystallized for pure sucrose, dried, cooled, and screened for size. This results in the classic white granulated sugar you see in kitchens everywhere. There are also other types of sugar produced in this process. Powdered sugar, by grinding, brown sugar, by mixing molasses back in, specialty crystals in cubes. Finally, sugar is conveyed to packaging lines. It's weighed and packed into bags, from industrial 50-kilo sacks to 1-kilo household packs, stored in temperature-controlled warehouses to avoid caking and contamination. From here, it travels to bakeries, grocery stores, and eventually even your cup of coffee. From lush green fields to high-tech factories, sugar's journey is one of chemistry, engineering, and tradition. Sugar production creates valuable byproducts: bagasse for biofuel, molasses for animal feed, and filter mud as fertilizer. Many sugar factories are energy self-sufficient, burning bagasse to power turbines. Water is recycled, and emissions are controlled to reduce environmental impact. Next time you stir sugar into your tea or bake a cake, remember, it's not just sweetness, it's science. If you enjoyed this deep dive, give us a like, subscribe for more behind-the-scenes videos, and comment below with a product you want us to explore next. Thanks for watching, and stay sweet.